Welcome to the 7th lesson and the second section of networking. In this section we're going to look at wired and wireless networks, although we've done a great deal of work on that already, so it's kind of repeating some stuff and maybe putting some flesh on the bones for other things. If you still don't understand, please get in touch. It's not an easy thing for everybody. And then we're going to start looking at things called protocols and layers. And that is going to be sort of mind warping, really, particularly with the layers. It's not going to form a great part of the exam, maybe 4 or 5 marks out of the entire exam. So I know it's going to be difficult to get your head around. Try to bear with me. We are really looking deeply into networks and how the information is passed around and what the routers do with that information. So that's what we're building up to in this next little series. But first of all, we really need to sort of go back over 1 or 2 things and make sure that you are fully aware of what wired and wireless networks are. And I'm going to introduce a new kind of network to you shortly. So this is it, wired, wireless networks. That's the whole title of this section. And protocols and layers are the 2 things that we really need to focus on to gain a deeper understanding. So this is the sort of work for the next few lessons. I count now 6 lessons. We're starting off with modes of connection with wired, wireless, and the new one, virtual networks. And within each, they sort of break down. So in wired, we've got something called Ethernet. Within wireless, we've got Wi-Fi and we've got Bluetooth. Then we're going to go on to encryption, then IP addressing and MAC addressing, which you've seen a little bit of already, which is fine. So there'd be nothing really new added there. Standards, that's kind of legal stuff. Or when I say legal, I mean what needs to happen between 2 computers. If you've got standards, then 2 computers can sort of communicate because they know where each one is. And then we're going to talk about communicating with common protocols, and that's what protocols are, communicating. And then how we communicate. Oops, I can see there I've made a mistake on the bottom. We've got the concept of layers. DNS hosting the cloud web servers and clients should not be there if that's from the last thing. I'll tidy that up in the next video. So your task really from this whole section in networks is basically acting as a consultant, somebody who's going to advise somebody what kind of network they're going to be needing. And basically you're going to be doing that by understanding how the networks are put together. I mean, they're all good. It doesn't matter which kind of network you use, but some are probably better for different circumstances. And you are going to compare the benefits and the drawbacks of them. So in particular for wired versus wireless connections. You will probably be asked a question in the exam on that. This is where the exam will be focusing. And you might be asked to recommend 1 or more connections for a given scenario. So they might say you're in a school, what kind of topology will you need? What kind of hardware will you need? That information. So if you've not really understood too much, go back over the lessons and see what all those things are. So Ethernet, right, we're on wired networks, Ethernet. Ethernet is just a term that we use, and really it's basically just connecting all the computers using wires, but importantly in a local area network. So we're only thinking about a network that is like the school network or a shop network or your home network, a local area network. We're not looking at a wider area network such as the internet or something that Amazon may have. And wired and wireless networks, like I said, we're going to compare the 2. They're pretty much the same thing, only 1 or 2 differences. They're both going to use computers, but wireless, you can also connect devices. There's not an Ethernet port, which is one of the reasons why I've used the word Ethernet, is because I need to talk about the port shortly. There's not a socket on your phone to connect to your router. So devices are not necessarily hardwired. they probably are sort of wireless. So your tablets and your phones, maybe your PlayStation sort of handsets are also sort of wireless, your headphones. They don't plug into the actual Ethernet using twisted pair cables. They both come with network interface cards. Remember, it's either card or connection, I think they use now. We will look at that in a little more detail shortly, although I won't go into too much detail with it, because these things these days are actually built onto the devices and you're completely unaware of them. But I'm going to talk about a network where it's not built on. You're going to have to add items into it. On a wired network, you use cables. You must use cables, and that's quite costly. But on a wireless network, you use what we call a wireless access point, which is great. Unfortunately, it's not very secure. So if you're passing bank details from your laptop or your phone, they really are at risk of being stolen. Where if you're doing it through a cable, outside interference is not, and interference by a person is not necessarily possible. They both use switches or hubs to sort of communicate between the different devices in the room, and I've sort of laid out routers separately because switches and hubs really are for computers that are in sort of the school, and routers are what you need to connect to the internet or other networks in other places. So I've put a note at the bottom: switches, hubs, routers, wireless access points can be separate, distinct pieces of hardware. In other words, you can walk into PC World and you can order any one of these items separately and be given a box with an item in it. Or, as what tends to happen these days, particularly if you have an ISP such as Virgin, BT or Sky, they will all come in one box. And so you'll have a router, a switch and a wireless access point all in the one box, or you'll have a hub, router and wireless access point all in the one box, the one package. So Ethernet is just the network, the local area network that we're looking at. So what is wireless? There's a couple of forms of wireless that we use, and we need to have an in-depth knowledge of what we've got, and I'm going to show you that on my own SkyHub shortly. It uses radio waves to transmit data, and the problem is with radio waves is that either they can be intercepted or they can be interfered with by other radio waves breaking up the signal. So we've got some work to do with wireless networks that we don't seem to have with cabled networks. If you are going to set up a wireless network, then you need something called a wireless access point. And actually, let me go to the hub at the moment, and it might ask me to log in a minute, but here we go. My box, the router, the switch, the hub, the wireless access point here, I've got a little box here to tick to say I want to let it be a wireless access point. If I took the tick out of that box and saved it, then no wireless device, no phone, tablet, laptop would be able to connect to the network. And there's another thing with this as well called a DHCP server. Let's see if I can go there under maintenance. It stands for Dynamic Control Host Protocol. And what it is, if you can imagine coming into room 25 and there's a person on the door handing you a number when you walked into the room. So the first person will get number 1, the next person will get number 2, and so on. But there's only one person responsible for giving out numbers. Imagine if there were 2 people on the door and they've each got the same numbers, and they were handing these numbers out. When one person walks in, you get number 1. But if the other person who's handing out the numbers hands number 1 out, I'm going to have 2 people with number 1 in the room, and that is not allowed. And it's the same on a network. A DCHP server is something that hands out the IP address, and it must be unique. And you can only have one in a network. You cannot have two. If you have two, you've got big problems with people having duplicate addresses. So why I'm mentioning that is because you can go, as I said, to PC World and you can pick up a very, very cheap router. So if you're having problems with your network, let's say you're upstairs and you really don't get a very good signal, then maybe you could buy some extenders which plug into the main system, and you can plug an Ethernet cable into the extender from your original box to a router upstairs, and that would give you the full 100 megabits per second link from downstairs to upstairs. And then you could use a wireless access point, which is just a router with two aerials, to boost your Wi-Fi signal so that you would get the full 54 megabits per second speed upstairs. But you would have to turn off the DHCP server. And we can see here that I've got a DHCP server for version 4, that's for IP addresses, and I've got one for the new version, DCHP 6. So this is set to on. So if I put a second router into my house to boost my signal, I would need to keep this one on, but turn the DHCP server off on the new device, and that would enable me to have a wireless access point only. But you need to set up your router to be a wireless access point. You can turn it on or you can turn it off, and as you can see, mine is sort of turned on. We didn't get to where I wanted to go. Anyway, that's a side issue. That's just some helpfulness if you want to boost your signal at home. If you want to know a bit more about that, contact me and I'll help you out. Oh, another spelling mistake. Lovely. Don't confuse wireless access points with hotspots, because a wireless access point is a device. It's a piece of hardware. It's solid. Whereas a hotspot is an area that has a wireless access point. It's just an area that you can connect to the wireless access point. So it's mainly used in shops or pubs or something where they say you've got Wi-Fi with us. That is a hotspot. It's not the wireless access point. It's just an area where you can pick up their signal. To connect, you're going to need a device which has wireless capability. You can't just walk in with a laptop and hope that it has wireless capability. Older versions don't. Many old PCs don't. You can still buy PCs that do not have wireless capability. Wireless laptops are the norm now, but never used to be. If that's the case, then you can buy something called a dongle. And here we see this is a dongle. It's a USB one. It just slips into the USB port and it turns your laptop or whatever you've plugged in into a wireless device. And notice the numbers on there, 802.11n. That's got some meaning that we don't really need to know for the course, but that is a wireless standard. If you remember, we talked about standards right at the top of the lesson. But this is called a dongle. I think the school have been giving out dongles to people so that they can access the internet even if they don't have internet at home. So it goes straight up to a satellite and you're given internet access that way. There are several different kinds of dongles, so be careful when you're buying one if you have to. We can have ones that plug into the computer. And if we were in school, if you took a look at the Raspberry Pi, that has got a Wi-Fi dongle inserted into it to give me Wi-Fi access on the Raspberry Pi. But there's also HDMI dongles that you can use, that you can stream high quality video to a TV. So you can plug it into your laptop and stream the video directly to your TV. Things are so clever these days. Even my TV is just wireless, or it's got, I think up here at the top, got a little rectangle with an arrow pointing up. That's an airport. So if I just click on that, my screen is mirrored onto my TV. Wow, all wireless. It's quite fascinating these days what can be done with things. So what is Wi-Fi? Well, there's two radio frequency bands, 2.4 gigahertz, that's ultra high frequency, and 5 gigahertz, which is just high frequency. And generally, let's go back to my Sky Hub. You'll see here 2.4 gigahertz wireless setting. So my router, my Sky wireless is 2.4 gigahertz. It's ultra high frequency. And that is split into a number of channels. So you can think of sort of the signal coming to your TV, but you've got BBC One, BBC Two, BBC Three, BBC, all the way up to BBC 14. And you can tune into any one of those channels. Now, the reason why you would probably do that is because if your next door neighbour has a router, a wireless router, on the same channel as you, let's say it's on channel 1, then you might get some interference. And what I mean by interference, videos might buffer, you might have a low signal because you're kind of sharing bandwidth and stuff like that. Although that's not exactly true, but it's going to affect it like that. And if that is the case, what you would do is choose a different channel. So you would probably set your wireless network up to be on channel 6, and that would remove the interference and give you full reception. And again, if channel 6 is sort of interfered with, you can go to channel 11. Now, these frequencies overlap. These are clearly separate and do not overlap. So channel 1 does not overlap with channel 6, doesn't overlap with channel 11, doesn't overlap with channel 14. They're all distinct channels. But imagine that I had to change and went on to channel 2. Then I've got some overlap with channel 1, which would cause some interference. But if my neighbour is set up on a particular channel, let's say channel 7, then you can see, don't know whether you can see the colour, the green there. That would be distinct from channel 7 and channel 12. So I wouldn't get any overlapping between those channels. So I might change depending on the interference. You can never tell what somebody else has been set up with, so you could change the channel yourself to whatever you want it to be. And when you are doing your wireless settings on your router, you will have something like here to say what the desired channel is. Normally it's set to auto, so it picks up the best signal strength, but you could physically change to a different channel to cut out the interference on your router. So Wi-Fi performance is affected by interference. Obviously, if there's two adjacent channels which are too close together, they're going to leak into one another, and your performance is going to drop off big time. Also, the frequency band that you use can also affect the performance. So the two frequency bands are here, 2.4 gigahertz or 5 gigahertz. And we really need to see what the advantages and disadvantages of these two are. We'll see that in a second. What I do want to point out, written in red at the bottom, Wi-Fi is not the internet. So whenever you read the words Wi-Fi, it does not mean internet. I know you probably think of Wi-Fi as being the internet, but it is not. It is the network. It is the radio frequencies that you are using. The internet is something completely different, but you overuse the term. You use Wi-Fi and internet interchangeably. So here we go, 2.4 gig versus 5 gig. Ultra high frequency is 2.4 gig, and it's got a greater range. So 25 meters, 100 meters away from the actual point, you can probably still pick up a signal. So we can have devices in different rooms if necessary. So that's quite a good signal range to have. It's also better at getting through solid objects and walls. And again, if you are having difficulty with your signal dropping off and you're only a few meters away, because you're going through a solid object or a wall, like being upstairs, then think about using the extenders and another wireless access point to boost your signal. It costs money, but it's worth it in the long run. The advantages of 5 gigahertz. Well, really 5 gigahertz is just high frequency. And really it's a shorter distance. So 2.4 has a great range. 5 gigahertz doesn't have such a great range, but when you are closer to the actual wireless access point, communication is very much faster. And there are more non-overlapping channels. So we saw with 2.4 gigahertz that just about every channel overlapped with another one. You had to sort of move along 6 channels before you didn't have an overlapping channel. So there's less chance of interference because of non-overlapping channels from 5 gigahertz. Bluetooth. Bluetooth also uses radio waves. I'm not really going to go into Bluetooth a great deal. The exam board won't. I just wanted to mention it as part of a network. You could set up a little network with Bluetooth, but mainly it just pairs between 2 devices. It's like having a dedicated wire between 2 devices, but using radio waves. And it is very short distance, less than 30 feet. That's about 10 meters. So, take 10 strides and that's as far as your Bluetooth will go. And it's normally used between 2 personal devices, so maybe headphones and your iPhone to play music, maybe between your TV remote control and your TV, maybe between your PlayStation handset and the PlayStation itself. They tend to be Bluetooth because generally you'll be in close proximity and you need that one-to-one pairing sort of access for you to use the devices. So that's Bluetooth, and that's about as much as we need to know about it. Really, it's just radio, short range. Okay, so I'm going to talk about virtual networks, but first of all I want to talk about a real network. This is a picture of a back of a computer, or diagram of a back of a computer, and generally they have one Ethernet port built in where you plug in your twisted pair cables. And on the other side of that, on the PC side, there's all electronic components. That would be your network interface card, but we call this an Ethernet port. Now in school, let's take a look at this. This box here represents the whole school network, and each network that you want to connect to would require a separate Ethernet port. So in the old days, maybe going back 20 years or more, before Wi-Fi was there, what we used to have was separate networks inside the school, and we had it for security reasons. So the admin network would be separate to a teacher network, which would be separate to the student network. So all the computers would connect into an admin network because they keep important details, personal details, sensitive details on their network, letters home, etc., doctor's information. Whereas the teacher network wouldn't require that information, so they would probably just need the software necessary to teach and maybe a link to home so it could remotely connect into the network. And then we've got all the students on the student PCs and they'd need a similar network, but not as great as the teacher network, and certainly not be able to access the admin personal information. But to do that in the old days, we would need to have 3 separate Ethernet ports, one for each network. And each network would require its own cabling, its own switches, its own servers. So it would be quite expensive to actually set up 3 separate networks or more. And they're quite common in businesses. You've probably got the boss's network who works out all the payroll. And then you've got the workers' network. It's common to have many networks within an organisation. And in the old days, like I said, you would have to buy a new card, plonk the card into your computer and then plug it in. So if you wanted to access to all 3 networks, you'd have to have 3 of these ports and 3 separate wires with 3 separate switches going off to 3 separate servers. Quite a lot of hardware, quite a lot of cabling, and quite difficult to manage. So we now have something called a virtual networks, quite modern. For me, it is modern. For you, it's probably old hat now. A virtual network is one that is created using software. It doesn't use hardware to make it work. It uses software. It's a program that runs on the computer. And a business or a school may want to partition off, so break into sections such as the admin, the teacher network and the student network, break off that physical network into a number of virtual networks, pretend networks. They're not really there. In other words, what we're talking about is that they don't have any hardware. There's no extra cabling, no extra NICs, no ports. It's all done via software. And each time we sort of break off one part of the physical network, that's the one with the hardware, we call that a VLAN, for a virtual local area network. So it can provide each department with their own little network securely by virtually, and there's lots of virtualizations these days. You can have virtual software. I often use it and have displayed it to you where I've got different machines running on one machine. They're called virtual. It's not physical. It's not a real computer. It's only in software. But having a virtual network instead of a physical network can have lots of benefits, apart from the fact that you're not cabling and going mad with all the switches, having different stuff. It only needs to have one large physical network in place. You must have a physical network. You can't just have a virtual network. The virtual network works inside the physical network. Every virtual network you've got inside there has got its own level of security and access. If you remember back, I said that the admin network would need to store personal details. So that would need to be secure so that people could not sort of log in and get access. And with a virtual network, we can manage that. We can change the level of security and the level of access based on what we decide is needed, really. So the head would probably have his own network with SGS where they just talk with one another, but there's no need for the teachers to know that, or the admin, or the students. So the level of security on each one is possible. And we'll see another version shortly. The bandwidth, as you know, it can be distributed, that's shared between each VLAN differently. So if one network is used more than another, so let's take a thought about the head and SGS. If he's got a network with the different schools as a virtual network there, then he might log on to it maybe once a day, just pick up stuff in the morning or do bits and pieces like that, versus the student network, which will be in constant use throughout the day. So we would give more bandwidth to the student network than we would give to the head's network on his side of the virtual LAN. Users within a large physical network that's in the room may not even be aware that a virtual network exists, and that is probably the case inside the school. You see your network, you log on to your network, but you're probably not even aware that there might be an admin network or an SGS network. Even I'm not aware if there's an SGS network or if there's an admin network. Virtual networks are kind of invisible to people who don't need to see them. And this can be imperative to the security of some companies, because if you can get access to a network or even know that a network exists, you can start tunneling into that network or try to tunnel into that network to go and see the data. And it probably wouldn't happen in a school, but I think that's a full-time job for most hackers, trying to tunnel into different networks. Then we've got something called virtual private networks, VPNs, and I've kind of distinguished between virtual network and virtual private networks. I've highlighted the word private in red because mainly this one works on a WAN rather than a LAN, and it's used quite a lot, and I've known lots of students use a VPN, particularly if they want to get around the school security. That is possible using a VPN. We can make use of virtual networks to keep our own personal data safe. Now that is really the purpose of the VPN, is keeping personal data safe. However, it's used for probably lots of different reasons, and I've given you 2 videos to watch to see how VPNs work. So it can be set up. In fact, I could set up my router to become a VPN. I've just got to, like everything else, just put a tick in a box and I've set it up to be a VPN. But I've probably got a little bit more work to do on it to make sure things are private. I've got to manage the encryption, everything else like that, which we're going to see a little bit later on. But you can log into a VPN from anywhere in the world. So if we've got a school and somebody's got access to the school remotely with another sort of, if I did it from home and then had a VPN on my home computer, then essentially you could log into my computer onto the VPN and you would have access to the school network. So yeah, it can be a little insecure as far as that's concerned, but it is far safer in the way it operates. Please watch the videos to see that happen. So what happens is that as information is sent around the internet, the packets of data. So if you've got an email, that might be broken up into 200 bits. Each bit would be called a packet. But if you're using a VPN, it's got an extra little bit in that packet. And we're going to look at packets a little bit later on. And it has that extra element to identify that it's from a VPN, which makes the data that's being transmitted secure. So not only might you not know that the VPN exists, the network exists, but even if you did know it existed and you try to look at the data, it wouldn't make any sense to you whatsoever, because it gives you a layer of protection that only the VPN that's been set up can understand, and that is down to you. And there are things called special protocols and encryption which are used to do this, and we will be looking at protocols and encryption as we go through the course. So that is my quick view of wired, wireless and VPN networks. Have a go at what I set you for an exercise, and we'll see you in the next lesson.